Thanks for coming, everyone. Imagine a world without mocks. This is test code. Does anyone know what it does? Neither do I. So I'm going to be talking about why mocks are just not a good idea in your software, and essentially the problem is that they always identify design flaws in your software that when you go back and fix them, they enable you to improve your code and then delete all the mocks. And this might seem an extreme position, that they're always a bad idea, but I will defend this at length tonight, and you can make up your own mind. So let's get rid of that. I've been doing Java for a long time and Scala for the last 5 or 6 years. I mostly write Scala at REA Group and evangelise functional programming and other fun things, that sort of thing. The stuff we'll be talking about today is mostly based on a blog post I wrote last year with a very clever play on words in the title. The TLDR of this talk is this. What's so bad about mocks and stubs? They solve the wrong problem. The problem they solve is how to test poorly designed code. So we're going to be going through a bunch of examples of this and examples of how you can improve the code to avoid the requirement to use mocks in your software. So how do we get here? How did we get into this place where mocks and stubs are the way to test our software? Well, we sort of, in a software system, we have many components that are kind of these little walled islands, and they talk to each other through messages, and you can't avoid this in a software system where things are talking over a network and they're different components. But with OO systems, this view of the world carries all the way through inside the code base at every level down the code base. So everything is in these encapsulated modules, I guess, that talk to each other. And so let's say if we want to test user service, we need to find some way to isolate it. It has two collaborators here, the auth service, and which it uses to decide whether the user is authenticated, and the user repo that it uses to, that's where it gets the actual user from. Now, we can't test user service in a sane way on its own because these other things that talk to do things out in the world, they have side effects. So for auth service, we can use a stub. And the great man, Martin Fowler, in this very, very famous blog post, defines stubs as something that provides canned answers to calls made during the test. And usually it doesn't respond to anything outside what's programmed in for the test. So we take away that auth service and we replace it with a sock puppet, essentially. And it narrowly says, if you ask me this specific method call, auth user, then I'll say true. And this is okay, because user service's input is now deterministic. Instead of asking this auth service out on the wire, which could fail in a whole bunch of different ways and is dependent on a bunch of ambient environmental factors, we have a fixed result from this call. So that's a good thing. That will help us. The other part of the user service is of course getting it from the database. I should stop at this point. I would encourage you to heckle me at whatever point in time if you have a question or an objection or something like that. I'll be making many points that seem very obvious to me, but may be new to you, and I would like there to be a conversation if you feel that there's something to say or something needs more explanation. So please feel free to put up your hand and interject. So now with this user repo, this is effectively the output of our user service. That's sort of the effect it has on the world. So we can rip that out and replace it with a mock. So the great man again, mocks are objects pre-programmed with expectations which form a specification of the calls they're expected to receive. And so once again, we replace all that machinery with another sock puppet that says, I expect select user to be called once. So instead of the effect that it has in the world being dependent on a bunch of real-world things that shift and change and will be in a different state when it starts and ends, we're cutting it off at the knees and saying, we're just going to detect that method call and that's it. We'll call that. That's all we care to to detect. So the output is now deterministic. So this is a good thing. We have deterministic input, deterministic output, and that means we can write a pretty sane test for user service. And this is why we all use mocks and stubs for testing. So far so good. So what's the problem? There is a cost that comes with using mocks and stubs that is widely acknowledged by even people that like mocks and stubs, but they will say it's worth it. I will say it is not. You can judge. So firstly, they are coupled to brittle implementation details. Fundamentally, that's just the price you pay. So for instance, if we change it, so we're calling a different method called auth local user, and let's say for argument's sake that this is still totally correct code for user service. User service still does the correct thing, but the stub has been narrowly programmed to only respond to auth user. So what happens when we run our test? Well, there's a problem. Oh my. It doesn't know what to do. Now we can just fix that test, of course, but when you have thousands of tests, tests that fail spuriously when the software under test itself is correct are toxic to your way of working and productivity. You simply can't tolerate them. So you need a better way of structuring tests if you can. Now the second point I'll make there is they somewhat miss the point of the test. If we look at this again, now again we're calling auth local user, the stub still doesn't know what it's doing, and for argument's sake, let's say it just tries to forge on ahead with a null result or something like that. The mock will still expect select user to be called once. And of course, the result is it complains. Nothing happened, it didn't get called, error, test failed. Now, the problem is twofold here. Firstly, what's the point of user service? The point of it, if someone said, I've got a problem, I know, I'll use user service. The problem they are trying to solve is that they want to get an authenticated user from the database or from whatever official blessed store contains the users. Now, the mock doesn't test that. It tests an implementation detail. It tests a method call that doesn't actually prove a great deal. And not only that, the problem here, the reason this test is failing is because the stub configuration was out of date. So the code under test is entirely correct. We have out-of-date stub configuration causing a test failure, and the failure is reported down here by the mock when something doesn't succeed. So this, you can easily imagine, could be hours of your time on an afternoon that you could spend doing all kinds of fun things instead. So let's go into a bit more detail and look at some case studies of common ways mocks and stubs are used and the design flaws that they imply and how we can get around it. So first of all is clumsy input. I'm sure you've seen something like this before. This is a config object that's got a great sprawling mass of different things. We have database stuff and things to do with potatoes, as you do, and things involving blood sacrifice, which may or may not be required to keep the system running. And using this config is potato service, but all it needs is potato variety and max potatoes. It gets them out of the config. All that other stuff it didn't need. And then it makes potato salad, I suppose. That's the point of this class, is it makes potato salad. So when we test, making a config is a bit hard and we have to initialize a bunch of crap we don't care about. So we mock it and then we tell it to return things. So this is actually a stub. The stub is programming this shim of a pretend config to return particular fixed values that we can depend on to make our test sane. Oops. Yes. So let's look at it. So the actual test then just tests that the salad contains the correct result. So this is not too bad. I mean, we've sort of fixed the input of the test so it's not going to flake out in a bunch of different ways. But what's the stub really trying to tell us? It's got a message if we care to hear it. No one's going to need all those things at once. That's why we've stubbed it, because it was hard to create. There was a bunch of stuff we didn't care about that our code was depending on. So instead, we can split that up into 3 different things. Nothing is going to depend on all of those things at once. Now it's 3 different things that code can depend on independently. So this, at a stroke, improves our code and allows us to only depend on what's required. So now our potato service takes potato config. But even now, it only takes 2 of the fields that are present in potato config. And don't we just need those 2 fields? Do we really need to care where it comes from? Because we're doing 2 things here. We've got the whole to make potato salad logic, but we've also got logic baked in on how to fish those input values out of a config object. Does that really matter for what we're trying to do here? And so we can rewrite this again, just passing in the values we require, the minimum of what we require, and the application wiring can be someone else's business. The problem of fishing out those values out of some config object, that can belong somewhere else. That's application wiring. That's a separate concern. And here's the test. Wow. So what we've got now is a potato service that we create directly with the values that we want to give it. It's a real potato service and real values, and then we just make salad and we check whatever we want to check about the output. Input, output, done. And how simple is that? You can't get much simpler than that in the test. Certainly better than all that looking and stubbing. And our Mr. Stub here is in the bin. Very good. So what have we bought ourselves here? We've written code, we've seen the fact that we were tempted to use a stub, and we've said, well, that flags that our code could have been more modular, more reusable, simpler, with less code, and then we get rid of the stubs. And that's what we did. That's a win, I think. Any comments or questions on that one before I move on?
What does the test look like for whoever calls the potato service?
Could you speak up, sorry?
What does the test look like for whatever object calls the potato service? You've said that you've taken out all the interactions with the
Yes.
services, and you say you're going to pull the config out and then inject it.
Yeah.
What does the test for that thing look like?
Yeah, sure. It depends what it's trying to do. I mean, the test should pertain to what problem that thing solves. And you know, if you've got a problem and you go, I know, I'll use that thing that calls the potato service, that's the sort of thing that you want to test for. And that could be a range of different things, and how you handle its interaction with the potato service, I think depends on that. So, yeah. But I'll go into more examples that will maybe shed some light on this question as well. Yeah, I'll go on. Very good. Okay. Case study 2, unnecessary mutable state. So in the traditional OO way of designing things, we have these domain objects that have mutable state inside them, and we don't want to share this mutable state everywhere. We want to encapsulate it in those objects, and so we hide all the private variables, and we have the tell, don't ask principle. So we have these high-level operations we want to perform: remove coins, insert coins, collect can, that operate on the state of each one, but don't leak it out. So that's good up to a point. So here, of course, we have a wallet with that mutates with the amount of money it contains, a drink machine that mutates with the amount of money it contains, the number of cans it contains, and whether the release tray contains any cans as well. And then the person who operates it varies with how much money he has in his wallet and whether he has a can of drink or not. So the code might look a little something like this. We've got a remove coins for the wallet and a way to query what level it's at. Insert coins, collect can, so and then buy drink down for our customer. It's very tell, don't ask. It's quite a conventional sort of OO setup, I think. The test, on the other hand, is unfortunately also quite conventional and a bit of an ordeal, I think. This one has stubs and mocks. because our two collaborators here are mutable and we can't test our drink buying functionality in any kind of sane way if we've got these mutable collaborators that we're running in line. So we rig the wallet to have a certain number of coins and return a certain number when it's called with remove coins. We rig the vending machine to return a particular can in the tray. And then we, as a way of testing whether it's worked or not, we sort of sniff around the wallet and vending machine and see if those methods were called with the right input. Remove coins 3, insert coins, and so forth. So we've separated the class under test now from its collaborators. But what are the mocks telling us? So the thing is here, our verification of this scenario is sniffing around the tea leaves and entrails for anecdotes and clues about what's going on, but we don't care about those things. We don't care that something called collect can or blah, 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 or whatever I call those other methods, because they're not relevant to the correct functionality. The correct functionality that any external observer of the system cares about is to do with the state here. The wallet must have the correct amount of coins in it at the end. The vending machine must have the correct amount of coins at the end. It must have the correct amount of cans in it in the end. And the customer must end up with a drink and hopefully still a wallet. So if we only care about the state, perhaps there's a better way we can structure this. And so the stub tells us, if the state is just immutable values, we don't have to force it to be isolated. So when you have a data structure that's immutable, instances of that class are essentially just values. Morally, they are values, like integers or strings. They're not a more complicated thing, a reference that changes over time depending on when you look at it or what's happened to it or where it's been. They're just values. And this instantly makes things so much easier to test. And then you need to ask the question, do I really need to separate that out? Well, no, you don't. It's already deterministic. The thing that you were trying to achieve with the stub has already been achieved. It's baked into what you're writing. So this can be rewritten. So now there is immutable state now, these interfaces. There is an amount in the wallet. There is optionally a can in the tray and stored cash and cans in the machine, in the vending machine. So this is all the state that we care about. This is the state that affects the correctness of this system. The customer has a wallet and potentially has a bunch of cans that he's purchased. And then also we have the actions that we perform, but in fact they're just returning a new copy of the data, of the state. They're not doing anything as such. They're returning a new value, a new immutable value. And so now, when we test, we can put our mocks and stubs in the bin because the determinism in our input and output that we were trying to achieve is already there. It's baked into the code. We can just directly create the customer with a wallet with whatever state we choose here. We create a vending machine. We buy a drink that results in a new vending machine and customer state, all immutable, and then we just check that those states have what we care about. This is precisely the intent of this piece of code, and we are directly testing it without any unnecessary moving parts. What we've achieved here, the code has less moving parts, it's more reusable, it's simpler, it's easier, and the mocks and stubs are gone. Yes?
Even though you are trying to reduce the number of mocks in your code, but you are introducing more and more code in your production code, that's in your logic for your interfaces.
What do you mean?
That's basically how you are testing something to use these mocking type of objects. But here you introduce more and more code in your production, that's in your logical interfaces.
Do you mean, are you suggesting there's more code here than before?
Yeah, that's right.
The main reason there's more code here than before is that Java's not very good at expressing this kind of stuff, and you have to do a bit of work. So these are all, in Scala, for instance, these would all be one-liners. So your language choice kind of matters here, right? But the effect that it has on the testability and reasonableness of your code is the same. So it still buys you a lot, going that extra mile to sort of do it in Java. But it's not going to look pretty on a slide. That's it. Yeah, up to back. Change the customer code to return a vending machine.
Yeah, that's fair. Why would I care about the vending machine when I buy it?
Because
Why would I care about, so first of all, the kind of value, whether it's a pair of glass, which always is smell. Is that a couple?
this, so this is an operation.
Vending machine, except for the test to assert its new value.
So this buy drink. This is an operation that starts with a customer in a certain state and a vending machine in a certain state, and it will result in a new state for the customer and a new state for the vending machine. So to express this in a pure function, it's just a function from a customer and vending machine to a customer and vending machine. So this expresses in a very minimal and clean way precisely the nature of this computation that we're performing.
Couldn't I set up the whole test exactly with, I'm not saying immutable values are bad, because it's great, I think also improve the performance and everything, but
Sure.
couldn't I just have everything mutable and have the test be simpler, just instantiate everything the same way you did, and just assert on the original objects and that would be it?
The thing is, if you have mutable objects, then you need to care about separating them. Because if you've got lots of mutable collaborators interacting, you can't run a test with all of them all interacting together. It's just confusing and flaky and hard to understand. And that's why we're seeing so many uses of mocks and stubs, is to forcibly isolate the thing we're trying to test. And that's what this seemingly simple mutable code does. It forces us to go to these extraordinary lengths to isolate and protect this code that could have been written in a way that was already isolated with no moving parts.
This example would actually be simpler if you just use the mutable classes and instantiate.
Well, it depends what you mean by simple.
You would have less VM1, VM2, VM3 objects that you need to track back and find which ones are which.
Yeah, so it might be less code, and that's just because that's what it requires in Java to express certain concepts. But when I talk about simple, what I think about is having less moving parts, less possible states that your system could be in, less things that are tangled together. And when you think about a particular part of your system, you can locally reason about it by itself without having to fit everything in your head and everything it touches and everything that touches and everything that touches. And it is an inescapable consequence of using mutable state that you are forced into caring what it touches, where it's been, and this kind of thing, because that's simply the effect that it has on the system. Now, when we talk about simplicity, I don't think of 2 extra lines of code. I think of the amount I've got to fit in my head when I'm trying to understand a piece of that software. And having immutable state and pure functions, we can locally reason about that. It's just a straightforward thing, input to output, you're done. You can forget about the rest of the system. If we make all these mutable, as you suggest, sure, it might be a couple of less lines of code in Java specifically, but all of a sudden, when we've got to understand it, we've got to understand everything. And when we test it, we've got to bludgeon it into being isolated instead of it already being isolated. Does that sort of make the point?
Immutable code is better, and I just don't see how this example makes a convincing argument to test.
Yeah, so I'm disputing your use of the word simple, in other words. So you're saying simple...
Would that being the same, just shorter and more understandable?
This...
Just shorter, more readable,
Yeah, so a couple of less lines of code to me is not what simple means. It's about there being less moving parts and less entanglement, and mutable state inevitably has that effect. Yes?
that business logic is inside the vending machine. You have to test that at the same time. This doesn't really fix the problem of, it doesn't make it really simple. Even with your definition of simple. Because you,
I anticipated this this argument. It would seem. So the reaction you often see when looking at this kind of code, all of a sudden, we're not doing the tell, don't ask thing, and there seems to be a bit less encapsulation. And in fact, yes, there is less emphasis on encapsulation when you model things this way with these immutable snapshots, these states, and simply functions between them. And yes, when we're testing the code, so for instance, the buy drink code, we're running the customer code and the vending machine code and the wallet code as is inside that one test. And I don't care. And the reason I don't care is firstly because immutable data structures are just values. Morally, they're like integers or strings or whatever primitive things. So you don't need to worry so much about that. And the other thing is, we don't have any really moral business peeking at the tools a method uses. Any given method will use certain tools to achieve its purpose. But how we gauge whether it fulfilled that purpose is by observing its results and effects. The tools it chooses are quite irrelevant. And when we have a pure functional one where we don't have side effects in place, really it's just, we're just allowing the method to choose its tools and just judging its correctness by its input and output. And so, I mean, you can call that an integration test if you like, but I don't care. Because the important thing in the separation that we try and achieve with unit tests and mocking is determinism. And we've already achieved that.
Yeah, the only problem with that is, sorry that I interrupted.
And that was the third point, yeah. Yes?
The only problem with that is that I do believe in that.
Sure.
Just trying to convince some other guys at the office, and the thing that they told me is, sure, but if you have a nested object that you're using, and it's very nested and used by everyone,
Yeah.
failure in that object will break your whole test suite. And then you have hundreds of tests that are failing. And that might, I say, I don't care, but I don't know what you think about that.
So, I mean, the question is, what's the point of the software? If the point is to achieve a certain state that the software produces, and then you change that state, well, I should think it should break the test, shouldn't it? Sure. You've got to change the test to reflect that. And that seems a natural thing to me. Yeah. Sorry?
I'd want to fix to a pre-test rather than 100. I think partly it's also about determinism, but it's also about isolating behavior to small tests so that if something changes, you don't have a flaw in it. You don't have to change a few assertions of particular behaviors.
Sure. Yeah.
Can you achieve that doing this if you have a big integration test or integration?
Well, I mean, I don't even call it an integration test, but it's just a function calling a function, but you can still set the granularity at which you have these things. You can have big functions that have got a lot of things happening under there. They're still deterministic. The same input will give you the same output. Or you can have sort of finer grained ones that are very small input and output. And so I mean, it's completely up to you how you structure such things, I think. The mental exercise that I like with this kind of thing, if you imagine a multiply function that takes two integers and returns an integer. Now, the implementation of this might be that it loops and calls an addition function, a certain number of times to implement the multiplication. Now, if you're testing that multiplication function, do you provide stub integers and then stub the implementation or mock the implementation of addition and check that addition got called 5 times? I mean, that's ridiculous. If you want to test what multiplication does, you put in two integers and check that you got the expected output. And the reason it's ridiculous to mock the tool that it's using, the addition tool that it's using, is not that it's such a simple example. It's because it has absolutely nothing to do with the correctness of the thing that you're trying to test. And it's already isolated enough. Multiplication is a thing that is designed to take in two integers and return an integer. And if you want to check it's correct, you just judge it by that. And so I would extend that, as I've said, any immutable structure is morally just a value like integers. And a pure function is similarly, just like addition, it's just a tool that it uses. That software is already going to be deterministic, and the same input will give you the same output, and you can just run it on those merits. Those merits being what the software is supposed to be doing, not sort of sniffing around the implementation details.
So, in the example, you've got, like, say, a customer interface, and you call a function that returns like a vending machine, and a new copy of the vending machine, and a new copy of the customer, right?
Yes.
So, why would the thing calling that interface care about, or why would it have to deal with the new copies of that call?
Because that's...
So it's putting more of a load on the caller about what to do with the copies of the vending machine. Because I assume at some point that state has to be persisted somewhere, right?
Yeah, I mean, the result of performing that operation is there's a new vending machine state and there's a new customer state, and just on that piece of software, we have no business assuming what other people are going to do with that. And so the next person, they might only care about the customer and they discard the other part, or vice versa.
And then you might lose some information, right?
Sorry?
There's no shifting the name, if I could put it that way, right?
Well, it's not minding things that are not our business. We've just got this very simple reusable building block, and other bits of code can recombine that with other things in whatever way they see fit. That's how I would put it. Okay. Should I continue? Yep. Cool. The next thing I want to talk about is essential effects. Now, the last one we were talking about a mutable domain model, which was essentially a thing that we chose, because we can always choose to represent our domain immutably just as easily. Well, maybe slightly less easily in Java, but any piece of software, the point of the software is performing effects, whether that be sending an email or putting stuff in a database or sending stuff over a network or something like that. So there are certain effects in the system that the whole point of the system is that it happened, so we can't just make them disappear in a puff of smoke. They've got to happen one way or the other. So surely we can use mocks here to help us with that. So here's a very simple example. So we've got an email sender that actually sends an email. It performs that effect and sends it out over the net. And we've got a special offers thing that, given an email sender, and given a customer, if the customer's not unsubscribed, it'll compose an email and then call the sender and send that email. So we want to test that special offers functionality. We've got some pure logic here. We're checking the unsubscribed and we're composing an email, but then we're performing that effect that we need to perform and sending an email. So the test might look like this. We're mocking the email sender because we don't want to actually send emails in our tests, of course. And so what we do then is verify that the send method got called with the things that we expected it to get called with. So that's not too bad. I think it's sort of minimally just sort of slicing off that effect, and it's making it deterministic. But what's the mock trying to tell us? Let's investigate. So here's the thing. Checking that mock doesn't actually check that you've sent the email. It checks that you've called the send email method. Perhaps buried in some other piece of code, there's email context dot don't actually send emails to true. And so calling send email won't actually send emails. It depends, we don't know. So we're not actually going to send emails in our test, and we're not testing that we're actually going to send emails. All we're testing is the intent to send an email. And that is actually the important thing that we want to test here. We want to test the intent, that the code formed the correct intent to perform that effect. And so why can't that intent be its own structure? We can actually call that a thing and return that instead. So here's, there's many ways to do this, and this isn't necessarily the best way. But for example, for argument's sake, we could have a structure called send email intent, an interpreter in some other part of the code that actually, given the expression of an intent to send an email, actually performs the effect. But that gets called in some other part of the code. We don't have to worry about it here. And then our logic with the interesting bits and pieces that we want to check, the composition of the email and the check of the subscription status, that's now a pure function. And given a customer, it returns optionally a send email intent. And now we've turned this into, we've moved the side effect away. We're still capturing the intent, which was all we were capturing before, and now it's more reusable and simpler and easier to reason about and all those nice things. So now the tests might look like this instead. We put our mock in the bin, we create our special offers, and we run the functionality, and we get back, I haven't written that right, that should be an optional send email intent. Oh no, I've said .get, that's fine, yep. And then we just check that it contains the things that we expect. So even though there was an effect that we had to perform that was essential to the running of the software, in fact, all we were testing before with our mock was the intent, and we've been able to capture that and pushing the effect away and turning this bit of logic into an easily testable and reusable and recombinable bit of software that's already isolated and doesn't need to be bludgeoned open with a mock. So what we did here, the pro move we did here was we separated the intent from the execution. And most of the time, the intent is the thing you want to capture. The execution is hopefully just a dumb trigger pull that is maybe not that interesting. And you can always set up an end-to-end test in such and such an environment if you want to really check that an email actually got sent. They tend to be more expensive to set up, of course, but that's really the only way to really know whether something gets sent or not. But the intent, we can do it like this. The code is more reusable, it's simpler, it's easier, and the mocks are gone. So that's another win. Yes, question?
So unless you schedule it as some sort of listener, the way listening for intent and process, in case you just test that, when did that integration, that test of interaction between sender and something else just machine in class?
Yeah, so I mean, can I go up? Yeah, so the responsibility to interpret that result has to live somewhere else, and that's fine.
How would you test that responsibility?
The interpreter, you probably wouldn't. You could test it in an end-to-end test, which is, that's the only real way to know whether you've sent something. But you would structure this so that every scrap of logic that can be expressed in a pure way lives in happy land, and the effective bit that actually runs the effect is this really, really narrow trigger pull that does nothing but just pull the trigger. It doesn't make any decisions, doesn't do any logic, just pulls the trigger. And so all the interesting stuff to test is pushed down into happy pure land.
Does it pull the trigger, or does it just put the bullet in the gun? Does it feel more like it's building the bullet and giving it off to someone else to fire it?
The thing is, we can mock the interpreter, right? And we can check that such and such a method got called. But we're still only testing the intent. We're still not checking that an email actually got sent. Like someone else might have said email context dot turn off emails or something somewhere else. The only real way to know whether we're sending emails is to run an end-to-end test. So what I'm saying is, then mocking the interpreter doesn't give you anything extra. It just captures the intent again, except in a more brittle way that's coupled to the implementation. But we've already captured the intent down here. Do you see? It's just because you're testing that method call doesn't prove anything. It doesn't prove you're sending an email. All you're doing is capturing the intent to send an email in a way that's coupled in a brittle way to the implementation. Yes?
These classes have some sort of responsibility, some sort of contracts that we can call send, and we know that sender is going to do it. And all those particular situations you're saying where mail and not send, I presume that you captured the unit tests for that send, right?
Yeah, so the unit test, the test for special offers is going to inspect that optional send email intent. And there's going to be certain, like, for instance, if the customer it gives it is unsubscribed, it would be testing, yes, we get back an empty option there, but we don't get back a send email intent from this function.
The logic will reside. If, for example,
Yeah.
you're saying that logic resides in the sender, if I understood you correctly, the sender would have its own unit test to ensure that if do not send email is set, it actually doesn't send.
But by sender, do you mean the thing that actually physically sends the email? So I would have no logic in that whatsoever. The thing that actually performs the effect, I don't want logic within 10 miles of that thing. I want that to just pull the trigger, given what it's told to do, and it just does it. And all of the logic that makes decisions and that performs logic and makes decisions, forms opinions about what to do, I want that 100 miles away from the actual effect. I want that to be physical data structures that I can poke and check and return from things and inspect.
So is the interpreter replacing the sender, or is it interacting with the sender?
Yeah, that would be interacting. Yeah, I've sort of taken the sender out of this, but yeah, the interpreter would be actually sending the email, yes. But it wouldn't be making any decisions or any logic. It's like the send email intent has the full instructions required to send an email. It's just a trigger pull. Yeah. So every scrap of interesting behavior that we could possibly want to test, we want to push it into happy land down here. Yep, up the back.
So who calls special office, send special office? Who calls that method?
Yeah.
How does the intent get to the interpreter? So how do we get that?
Yeah, well, that's a good question. And that's an app wiring concern. And I've deliberately left that vague.
You test that. How does the test for that look like?
For app wiring.
For the fact that the intents actually get to whoever needs to interpret it.
So, I mean, the interpreter operates on a send email intent. So there's some big thing that would sit on the end of some big thing that has some sort of input, and then at the end of it, it spits out whatever description of the actions it wants to perform. And then the interpreter just dumbly just performs the actions it's told to. So
at the same time, there's no proof that the intent is ever going to get to the interpreter.
Yeah.
You might have this fantastic interpreter that performs the action perfectly, and it only performs the action, but there's nothing saying that the intent is being.
Sure, but there's no reason why we can't do that though. It's just someone else's business. It's just it's a separation of
So
concerns.
when it is your business, how would you test that based on this?
Well, I mean, my example here.
Test sooner or later.
My example here, my point here is that this makes sense as a unitary piece of logic without that wiring, and we can have a wider thing that.
That worry is your worry.
Sure. Yeah.
Yeah.
Yep.
How would you test that without using mocks and stubs and other things, other than going the most expensive path and having a giant integration or a system test or whatever in a real life scenario? So maybe like when all implementation of every single component is done for your application, and then you can finally check that it works. There's no proof.
The great thing about pure functions without side effects in place is that you can kind of forget about all the little thorny details inside it. It's a black box. It's just input output, and so some people you hear this slogan every now and then: functions in the small, objects in the large. But it's a load of rubbish, really. Functions work just as well in the large as they work in the small because they're composable, and so the whole system can be as simple as whatever input, request, or whatever output, response, with just the interpreter sitting on the end to actually perform the effects. And so...
So when you are
and,
writing the pure functional test for
yeah.
the actual thing, you would still have to create the special offers, you still need to have the interpreter, you would have to have everything all together so that that function can perform for itself.
Yeah, I'd just run it all. And but I wouldn't even think about the insides of it. I just think of that as a single unitary thing that has this input and this output, and I don't care about all the stuff that happens underneath. Now, your module boundaries, where you choose to draw the lines, is important. And that's a matter of judgment. Like it is with any piece of software, where you draw the module boundaries is essential. And that's not something I can say off the top of my head, because this is a completely made up thing, and we can only speculate on what the whole system looks like. So yeah, I would say for something that already doesn't have side effects in it, a pure function, I just care about the input and output, and I don't really care about what happens inside it. And the rest is just drawing module boundaries in a way that makes sense, if that makes sense.
But I see that these things are not things to have.
What was that, sorry?
What I don't understand about this way of testing is that it at the end promotes huge integration tests, right? Because when you, so for example, using send a special offer, there should be some logic outside this thing that says, all right, do I have to send a special offer to this customer? Yes, I do have to send them. All right, so just get special offers and send them, right? So that logic needs to be tested.
Yeah.
And I don't want to mock special offer. So now I'm writing a test with the real special offer. And that thing will just add more layers on top of the object, right? So you are actually testing integration tests at the end. And at the end, it will come with all of the functionality tests tested from the top level, basically. And then you add more tests every time you go down.
Yeah.
And I do agree that. I do
Sure.
believe in that. The only problem, again, is that a problem in the add function will break the whole thing. But, yeah, I'm just saying.
Yeah, as it should.
It should.
It should. So a pure function, I mean, there's such and such an input and such an output, and it might do all kinds of crazy stuff on the inside. So it can choose its tools, it can choose the things that do the stuff on the inside. If it chooses something that doesn't provide the output that it requires, it's broken. So I completely want that to fail. So I mean, I don't care. You can call that an integration test, I don't care. And part of the overarching point that I'm making tonight is to get away from this mental model of collaborators, where that's the point where you want to cut things off and separate our things and get rid of the collaborators. Actually, side effects are the active ingredient here. Side effects are the thing that make you want to separate the collaborators. And once we've separated the side effects, all of a sudden it doesn't matter that much anymore if we're running a bunch of stuff, because the functionality composes. It doesn't become more complicated in a sense when we compose these functions. It's just input to output still. And we don't have to keep the whole thing in our head. And that's important. That's really important. Oh, sorry. Yeah, up to back.
Sorry, so we have the special office and the center, and we have to use multi-testing. Now we have special office and center saying the email intent. The sender didn't go away, we still need the sender.
Yes, something has to send the email.
We need an unidentified piece of glue that sticks everything together and connects the interpreter with the sender.
Yes.
Or basically the outcomes of the special office and special office method with the interpreter. So haven't we made the production code much more complicated in order to reason that by removing the mods?
And again, it comes down to what you mean by complicated. I don't think so.
In kind of less obvious way.
Because so the old one, the original example with the email sending in place. So it was doing all these decisions about whether or not to send the email and what to put in the email. And then it was also deciding what the next thing is. Once we've decided what to send and whether to send, it was also deciding what the next thing does with that information. And it was going ahead and sending it. And so when we tested it, we didn't want to send an email. In our tests, we just wanted to test that it had come to the right decision on whether or not to send an email and what to put in it. But because it was entangled with this decision on what the next thing is, we had to bludgeon it open with these power tools to mocks and stubs. So.
Because when that method would have been, finished, ejected off the stack, then the sender would have been called, and the email would have been sent if the sender would have done the job. Right now, I have a method that calls itself send special office. It actually doesn't do anything, so it misleads by its naming, misleads the reader.
Well, we can call it whatever we want.
So it signals what is my intent to send office would be a better name, because that's what it does.
Well, if you like, sure.
It has an if clause, which you didn't need to have, an else, basically an else clause, which you didn't need to have before, to signal not do anything. And I would find it more difficult to reason about the production flow if I had to request that, especially if I had to figure out why emails are not being sent. Then it would be really interesting, especially if I'm new to the project and I really want to understand the pathways of the call.
Sure.
I'm not just following the link to the send method and just going in and seeing what's going on.
So I mean, fundamentally what it's doing, I mean, apart from naming and cosmetic things like that, fundamentally what it's doing is decoupling the intent, which is the thing that we were trying to test, from the action that we perform on it. And I don't think I made it more complicated. I think I made it simpler. The stuff that we were.
You guys work that out.
I'll keep moving. Okay, no worries. All right, sure, no worries. Yes. All right, have I got time for one more subsection? Okay, right. The next one will surprise some people. Mocks kill TTD. So, what am I talking about, right? Mocks go hand in hand with TDD. All the TDD proponents love mocks and stubs. And the thing is that TDD, test-first development, is fundamentally a design methodology more than a testing methodology. It's about writing your tests first to make sure that when you write the software, you've got enough separation of concerns in there to make it testable. And it forces you to think about these things up front. So that's all well and good. So it encourages you to design code well enough to test and no further. And the trouble is that when you've got mocks and stubs, they set a really low bar. Pretty much anything's testable. And so TDD, which is supposed to make you think up front about how you can factor your code in a really good modular way, only gives you an incentive to do it to only a very small extent, because you can crack it open with these power tools again. And this really guts its value as a design methodology. And so I find that often TDD code that uses a lot of mocks and stubs will actually have a really terrible separation of concerns, because it doesn't need to have a good separation of concerns. So this is a negative side effect, I think. So in conclusion, side effects are the real killer. So we have the traditional model is you have collaborators, and you try and isolate your object or whatever it is, your component, and you try and cut off the other collaborators to isolate it. And that's not a bad thing. But the active ingredient here, the thing that makes you want to separate those other components, is the fact that it's not deterministic. You need stable input and stable output, the same answers for the same questions. And side effects are the thing that makes that hard. So once you get rid of the side effects, then you're in the right place for testing. So let's ask Mr. Stub and Mr. Mock what the lessons are. All the stub does is make the input deterministic. If the input is just immutable values, then you don't need it. It's already deterministic. We've built that isolation into the software. We didn't have to force the test to be isolated. On the other hand, if you're just using a stub because stuff's hard to create, get back in there and redesign the software. You can make it easy to create. You can make it smaller or redraw your module boundaries so they make sense. Mocks essentially make the output deterministic so that you can detect the effect of your code without actually running effects. But that sometimes means that all you're testing is this pointless web of lies that doesn't even get close to what the code is really about. Other times, the mocks test the intent of the code, and that's okay, but we can write the code so that it directly expresses the intent as a structure. We don't have to couple that expression of the intent with the execution of it. So here's my conclusion. I've got some sacred cows on the chopping block here. Forget about collaborators, because side effects are the real thing that you want to get rid of to be able to test your software. Forget about tell, don't ask, because that inherently means that you're performing effects. Effects are the thing you want to get rid of. If you have to perform an effect, then tell, don't ask is okay, but you want to get away from that if you can. Avoiding static methods and avoiding new are red herrings, because the reason why people avoid them is because it makes it difficult to, they're difficult to swap out. But if they're not performing side effects, then you don't want to swap them out, you don't care. So that's a kind of a red herring as well. If you're using immutable types and pure functions, then you're home and hosed. Your software is testable, your software is simple, reusable, modular, composable, and all these wonderful things. And that is the end of our friends here. Thank you.